Hopefully it works. It appears to be working. Awesome. So welcome to Des Talks episode number 4. We're lucky to have Mark and Tim from Carbon Revolution to talk about all things carbon fibre wheels. We'll just start off with a bit of a housekeeping and some other things. Share my screen. Is that working? Yep. Awesome. That works too. And I've gone, oh no, that's right. So just welcome to country. So as we gather for this meeting, physically dispersed and virtually connected, let us take a moment to reflect on the meaning of place, and by doing so, recognise the various traditional lands on which we do our business today. We acknowledge the elders, past, present and emerging, of all the land we work and live on, and their ancestral spirits with gratitude and respect. A little bit of an overview. We'll start off by introducing all of us panellists. We'll have our presentation / discussion about Carbon Revolution. If you have any questions during the webinar, use the Q&A function down the bottom of Zoom to ask those, and we'll do our best to answer them on the fly. And any other general chat things, feel free to throw anything in the chat as well. So I will start by introducing myself. My name's Trent. I'm the president of the Deakin Engineering Society, and I'm a third year civil engineering student at Deakin. And I'll hand over to Matty.
So my name's Matt. I'm also a third year mechanical engineering student at Deakin, and I'm the vice president of events at Deakin Engineering Society. And now we'll get Tim to introduce himself and just state what your role is at or your position at Carbon Revs.
Sure, thanks.
Yeah, quick introduction.
Thanks, Matt and Trent. And yeah, thanks for inviting me to participate in this. It's nice to be able to communicate these sorts of things in this day and age over Zoom. So I appreciate that. My name's Tim Souza. I'm the engineering manager at Carbon Revolution, particularly for all of our North American programs. I've been with Carbon Revolution for about 2.5 years now. So we've come a long way in that time, and on a massive growth trajectory into the future. So it's an exciting place to be.
Absolutely.
Yeah. Awesome. Mark, go ahead and introduce yourself.
My name's Mark. I'm a Deakin Engineering graduate and a product engineering intern at Carbon Revolution. I've been at Carbon Rev for coming up to a year now. I started my internship in November last year, and like Tim said, heaps has changed just in that time that I've been there too. So pretty fast-paced environment, and yeah, lapping up the experience.
Perfect. So first up, we'll start with a bit of your experience at Carbon Revs, Tim. My first question is how you got the job at Carbon Revs. Did you jump straight into the engineering manager position, or did you sit there somewhere else and work your way up? It's only been 2 years, so it's all happened quite quickly.
There's a bit of a running joke at Carbon Rev that we operate in dog years. So, you know, two years at Carbon Rev's like 14 years anywhere else. And
absolutely.
So when I first joined Carbon Revolution, it was heavily sort of driven at the time by being in and around that carbon fibre composites industry. So prior to me joining Carbon Revolution, I was working at Quickstep. Technologies, who are also based on the Deakin waterfront, Waurn Ponds campus. And I was a design and simulation specialist engineer there. So I looked after their design and engineering team in that role. And then kind of got attracted to Carbon Revolution at the time with some big growth potential that was happening in the business. Obviously got engaged with the guys there and started my role at Carbon Revolution as a senior product engineer.
Yep.
And so my role there is very much to look after a particular program. And at the time it was all North American programs, particularly one of our big customers, Ford. So my role there was very much around the nitty-gritty detail design of one of our wheels that's now on the GT 500 Shelby GT Mustang, which was a bit of a groundbreaker for us in terms of some of the technology that went into that wheel. And it was a lot of hurdles, a lot of challenges, a lot of making decisions quickly, but we've come out of it bolder and better, I think, and that's been really exciting. So I held that role for about 18 months, and then moved into the role looking after the North American programs more broadly. So with a couple of our other customers, which we have programs with, and also new development programs that are coming down the pipeline with some of our North American customers. So my role at the moment involves a lot of customer engagement, program management of those particular programs, and also looking after the other product engineers and our CAD and CAE teams within Carbon Rev. So it's a bit on my plate at the moment, but lots of exciting things happening.
Yeah, cool. Is the Ford program the only North American one you've got going at the moment that you're allowed to share with us?
No, so there's 3 programs that we have with Ford that are, I guess, in the public domain. So the first one is obviously the Ford GT 350 Mustang. That was our first OEM program to make it through to production with Ford. And that was a huge success from the get-go. It's obviously the first production carbon fibre wheel to come on a vehicle as a production option. Then the Ford GT followed that pretty quickly afterwards, which is a really iconic vehicle as well. And so we were really fortunate to be able to supply wheels to that program. And that's still got quite a while to go in terms of the life of that program. And then naturally it evolved from the GT 350 Mustang into the GT 500, which is another icon in that Mustang family. And that car's an absolute monster. 750 horsepower. It's breaking track records all over the place. And the volumes that they were demanding for that particular program were a significant jump on what we had previously built for other Ford programs. So as part of that, it really brought across, a number of new processes that we had to develop and then validate from a product and process perspective, which was all really successful in the end.
Yeah, cool. All right, Mark, we'll start with you now. Bit of an explanation on your past experience, how you got your grad position or your internship at Carbon Revs, what sort of thing, how you've got there, what you studied, how long you studied and all that. What sort of things helped to get the job, what you do in your day-to-day work?
So I'm a mechanical engineering graduate from Deakin. I did all your kind of typical mechanical subjects and really enjoyed probably manufacturing and stress analysis and materials were probably my favourite units. So kind of looking at that kind of work, I really liked the composite side of things and did my final year project with an academic that does a lot of research in carbon fibre composites. So going through that, I really enjoyed all of the work I did with composites, and looking at Carbon Rev kind of felt like not just the composite side of things, but the culture really fitted really well. I have a few mates that were working there and they always spoke really highly of the company. So kind of wanted to be working on, really cutting edge work and then also be working with good people as well and enjoy what I was doing. So I kind of chose Carbon Rev as the end goal of my degree once I started getting right into the nitty gritty side of composites work at uni. And then I think the thing that probably helped me the most to get this gig was by having my involvement with Des, and during our industry dinner, kind of buttering up the owner of the company and getting to know some of the guys up there and making myself known well enough that when I went for an interview, it was fairly comfortable and felt like it was the kind of place that that I really wanted to be at, because I was scouting them out as much as they scouted me out when I went in for the interview. So, that was kind of my way of getting the job. Yeah.
Yeah, cool. That's interesting. Go Des, getting jobs. So how long have you been there now?
How long have I been? I've been there. So my internship is a 12-month program, and that started in November last year. So probably coming up to the end of that now.
Yep.
We had, I think, 5 or 6 interns started the same time as I did, and we were all fresh out of uni. So we've been going through that all together at the same time, which has been really good too. So it's been a really well-structured program that we've been involved in. So I'm in the product department specifically with Tim, and there's a few other interns across the other departments that we have in manufacturing too. And we, catch up every couple of weeks to have lunch with a different executive. And when we first started, we were doing a lot of inductions on specific processes along the line. So if you look at our injection process, we'd go along with the lead engineer on that part of the factory and get a really in-depth explanation how different parts work. And then we can, ask all the really, enthusiastic questions on how does that work? That's so cool, kind of thing. So it was really satisfying to get that kind of in-depth knowledge really early on. So yeah, the internship program itself was, well structured and heaps of fun in that regard.
Yeah, cool. So it sounds like you did a whole lot of learning for a start with the other interns. Did you end up settling into a spot where you sort of ended up doing day-to-day work and commencing projects that were a bit more long-term? Once you did settle in, what was the day-to-day work that you did?
Yeah, so yes and no. I have been working on kind of similar stuff over a long period of time with particular projects, but the goalposts change pretty quickly and pretty often too. So I'm kind of working on, main projects at once that kind of span a longer amount of time, and then helping out with bits and pieces here, especially kind of supporting the more senior product engineers as well. So I've kind of took on a lot of work with supply development, and without going into too much detail, but the geometry that you cut for your shapes that go down to actually lay up the wheel like you do with composites manufacturing. I do a bit of work around the geometry of those and making the cutting files for that kind of stuff. So supporting a lot of trials on, changes to do with the internals of the wheel. I support some of the other more senior engineers on that kind of stuff too. So ongoing, I've done a bit of that work, and now I'm kind of getting into sort of the project management stuff for the first time, and coming along to some customer meetings and kind of, getting a feel for how things work in an external professional basis as well, which has been pretty eye-opening as well. Pretty fun.
Interesting. Over to you, Trent, for the next part.
Well, just quickly on that, Mark, you said about your networks before. Would you say, like, if you were to give advice to a new graduate or somebody who's potentially going to graduate at the end of this year, would you say those networks are something that's like super valuable in terms of finding positions like what you've got?
Yeah, certainly. One easy way to get into networking as a student, there actually are quite a lot of resources available to you as a student at uni. So particularly at Deakin, and it doesn't take long for you to start spruiking it, but if you're a DES member, you can go to, the industry dinner is a great opportunity to meet a lot of professional engineers where you can have a beer in a pretty informal environment, but heaps of guys get jobs from that. Or, you can build up a really solid LinkedIn profile and start chatting to engineers around the area too. But even just being at the Deakin campus as well, if you go and have a coffee up at the NA building there, you bump into all of us from Carbon Rev, or engineers from Quickstep, or researchers from around IFM. So if you're interested in the kind of work that we do in, that fibre hub that we're building around Deakin, the opportunities for networking are pretty in your face there. So there's a lot of opportunities for you at uni when you're at Deakin.
Yeah, obviously when things get back to normal slightly, and
exactly.
We're allowed on campus. No, thanks for that. That's great. So Tim, I'll probably throw this one over to you. Just a bit on what Carbon Rev is all about. I don't know if the full story, but like how did things start, I guess, and where did like the project start?
Yeah, that's it's a really interesting story. It's a bit of a fairy tale story, to be honest. A lot of it actually started from Formula SAE at Deakin University. So at the time, Ash Denmead, who's one of the founders of the business, and a lecturer at the time, Dr. Matthew Dingle, were kind of really the catalysts behind getting this up and running. And they came up with this idea of building a carbon fibre wheel for the Formula SAE vehicle at the time. And so, took that on, and before you knew it, it was an interesting idea that turned into a really solid idea that had a lot of technological benefits in terms of what it could offer vehicles from a weight saving perspective and outright performance efficiency. So, pretty quickly they had a technology on their hands that was, really disruptive, and we use that word a lot, disruptive to the current industry for wheels, for alloy wheels. And it really sort of started from then, and the guys spent a lot of time just developing the product, and literally in the back shed of Matt Dingle's place. It started there in sort of 2008, building the very first prototypes and kind of just working out the manufacturing process as part of the design. They were very much intrinsically linked, making sure that you had a process capable of achieving the design intent, and from there I think that sort of lasted in a small shed at the back of Matt's place, and then grew into a shearing shed on the Deakin University campus. And I think the guys were there from 2009 till mid 2014, 2015, where they kind of really started to get the production facility up and running. So really engaged with a number of automotive companies internationally to further develop the product, gain interest, and also put the product through all of the rigorous testing and validation standards that it needs to meet before it can make its way onto a customer vehicle. And then I think in around 2015, 2014, we built the facility where we are now. It's a bit smaller. It was a bit smaller back then. I think it was around about 3,000 or 5,000 square meters. Now we're close to 10,000 square meters and have the ability to extend another 5,000. So pushing us up to sort of 15,000 square meter facility. So, really has gone from a shed to a state-of-the-art 15,000 square meter facility. And this facility has the capability of, producing, in the order of sort of 200,000 wheels a year. So we're starting to become a big player in the wheel manufacturing business, where we are on the Waurn campus.
Absolutely. As you said, disrupting the market. Totally.
That's it. Yeah. Yep. It's it's not only disruptive from a vehicle efficiency and performance perspective. I think it's the aesthetic appeal of the wheels as well. It's so unique and different that it's not only a performance product, but it's almost like a piece of jewelry on your car. And so it's those two things that really make a big difference.
Yeah, sweet. So I guess that sort of segues into my next question. Once again, I don't know how much of this you would have seen firsthand, but the manufacturing, you're saying you started from a back shed to a shearing shed, and that, how has the manufacturing come along from doing a lot by hand to a lot more automation?
Yeah, that's exactly it. So, it was very much a bespoke craft, I would say, where, you had really highly skilled people with a knack and the right touch to be able to sort of lay up these wheels. And it would take a long time. You'd be talking a day just to lay the thing up, and then, days for injection and processing of the wheel, so on and so forth. It's gotten to the point now where we've really broken down the manufacturing process into a series of industrializable steps. And that all comes together with the use of robots, carefully designed and bespoke sort of machines that we use to build various parts of the wheel. And and that's only sort of the tip of the iceberg, I think. We still have a little bit of manual intervention in a lot of those processes, which we are starting to sort of design out. And, this is all in the idea of reducing the labour content that we put into building a wheel, to reduce the cost of it, to be able to make the adoption more widespread on other vehicle platforms, rather than just being on a $1 million Ferrari or a $150,000 GT Mustang. So yeah, there's definitely a lot more to come in the way of automation, but we've taken a really large step down that pathway.
Yeah, and with sort of standardizing that process, you've been able to move into the OEM market and secure a lot of these big deals, like with Ford and stuff.
Yep.
I imagine that was a huge contributor into securing these deals, and no doubt what's planned for the future.
Absolutely, yeah. A couple of the really key things that we need to be able to demonstrate to secure automotive supply to an OEM is, one, you need to have a product that can live up to all of the validation requirements, and the stringent testing that it has to meet. The other two things is you need to be able to demonstrate a track record of being able to reliably produce high quality parts within very tight tolerances and very tight specifications. And both of those two things come hand in hand with having a stable, a well-engineered and a robust manufacturing process. And industrialization of that process is essentially just that, taking something that might have a fair bit of noise in the manufacturing process and really filtering it and fine-tuning it so that, when you start banging out 1,000 of these things a day, they're all identical. They all meet and achieve, the right quality metrics to be able to be put on to customer parts. That's a really important part of what we do, and remains a bit of a challenge for us growing forward. As we grow so quickly, we need to make sure that we're always maintaining, that first class level of quality.
Yep.
Great. So Mark, I might throw this one to you if you're comfortable. Just loosely talk us through the steps of how you turn small little carbon fibres into a wheel.
Yeah, so broadly, composite manufacturing kind of starts with your fabric and then your resin. So you're putting two materials together. So it's kind of similar to making a surfboard when you think about it. You have your foam inner, and then you've got kind of fabric around it, and then you kind of hold it all together with the glue that is the resin. So we start by having all of our fabric just on a flat 2D surface, essentially just as fabric, the same way that you used to make clothes. We cut that into really weird looking shapes, and then you drop that into your mold, and that's in the shape of whatever wheel that you're trying to build. And then you have your foam kind of cores into that, and all the other parts that go into a face, and then you start wrapping it up and making the rim to it as well. And then that goes through to the injection process, and that's where you squirt it with your glue that holds it together. And then that flows down the line to be, cleaned up here and there and painted and all of those other aesthetic parts of the process.
Yep.
And then it's assembled all together and put in a box and sent to Italy.
That's sweet.
I guess one of the interesting things, when you compare us to an alloy wheel is typically it's one piece, there's one element to it. To build our carbon fiber wheels, in some cases we have close to 200 individual components that go into that wheel. So, and each one of those components has to be painstakingly prepared, measured, checked, quality approved before it makes its way into the wheel and becomes an injected composite part. So it definitely means, from an engineering perspective, the amount of engineering that goes into our wheels, it's almost like 200 times that of an alloy wheel, I'd like to think. But there's definitely a lot that we we fuss and finesse over microns when it comes to building these things, and I think it's why we can do it and nobody else in the world can at the moment.
Yep. Is there ways that we've already spoken about like the automation side of things and where the company's looking to go. So that's kind of just ticking off the boxes of making it more economically viable by making the process more efficient. It sounds like through that, being able to add in more technical designs and obviously develop the wheels a lot. So the wheels are one-piece carbon fiber wheels. Do you have any information you can share about the difference between other companies, like the problem that they have and why they can't do it? I suppose it's the secret, isn't it?
Yeah, it is. I guess when we look at it, knowing what we know, we find that it's actually quite simple to achieve that. But I think it's because we've developed it that way and it's just ingrained in our thinking of that's how it needs to be done. Essentially, the wheel starts as its life as the face of the wheel, which most other carbon fiber wheel manufacturers that then try and join that to an aluminium rim. That's where it starts. We have a fairly unique process whereby we combine the face and the rim with sort of specific tooling and a rim layup process, which kind of merges the two of them together prior to injecting it. And the success there really is in the design, the way that we've been able to design that interface between the face and the rim, and then also make it manufacturable, at high volume situations. That means that it's been really successful. One of the enabling technologies here was a process that we call auto rim layup, or ARL. And that's quite an interesting technology in itself. It started off as a one machine that we used to have, which we call an ARL 1 machine, and it was very much an R&D machine, and it revolved around a machine, but there was a lot of manual intervention, a person having to feed in plies of fibre and so forth.
Yeah.
We've since then evolved that through ARL 1, ARL 2, and we're about to launch an ARL 3 series machine, which actually takes a lot of the labour component out of it. And you almost basically load the tooling set onto this machine, and it does the majority of the work for you without an operator having to actually be present even. So, that's probably a good lineage of how we've gone from, a fairly manual process in an area where it's sort of one of our unique features which allow us to have this single piece wheel.
Yeah. Do you have any idea on the comparison of time that it took back when it took a day, the very first few wheels, or the first few years of manually laying up the wheels? You said before it could take up to a day, compared to how long it takes now?
Yeah, so we've broken the process down into, I guess, 20-minute steps, if you like.
Cool.
So
does it take 20 minutes for that whole, not the whole layup, it's still a process on different machines? And
that's right. Yeah. So, but yeah, by delineating it down to sort of these discrete 20-minute steps, it allows you to, produce a wheel every 20 minutes essentially. And then it just gets duplicated by the number of tools that you have in operation, or the number of machines that can process that. I don't want to quote a time, but yeah, it would have been, probably a couple of days to lay up a wheel when the guys first did it, back in the days of manual vacuum bagging and, tubing and stuff like that to infuse parts. Now it's all very much, you load a preform into a machine and it does the rest of it. Everything's tooled surfaces, everything's very much automated in the way that the tools move from station to station, and that all of those efficiencies just result in higher quality parts and improved throughput really.
Cool, yeah, it's an insane difference. We might talk a bit about the current projects you guys have got going on. We'll start with the GT500. Maybe a quick overview of the wheel, how it's different from other wheels, and particularly the GT350R wheel. It's kind of the, I guess you'd call it the generation before this project.
Yeah, certainly. Yeah, so the GT350R was our very first OEM wheel, and it was built off our aftermarket wheel. So when the guys kind of really got stuck into supplying wheels, we used the aftermarket market as a soft entry point, essentially. So we were supplying wheels to Porsches and top end BMWs and Audis and so forth. The GT350R wheel was a very similar design. It's a soap dish design. That's what we call it. The center of the hub looks a bit like a soap dish, where it dishes down to where the lug nut inserts would recess into. And it was built off our technology at the time, which was a low pressure molding technology. The GT500 wheel is a filled hub design, so it enables a lot more styling flexibility over our soap dish design. The aesthetic of the wheel has a lot more complexity in its spoke design and in through the center hub as well. So as part of that, we had to engineer in a number of new product content, specifically how we fill that hub with a core type structure. We produce all of our internal core structures in-house, based on a bespoke material that we actually designed specifically for the use in the wheels. So it's not like we purchase foam cores from an external supplier. And that was a difference between the GT350R and the GT500. We also engineered a region of the wheel where we produce a fiber preform where we can vary the fiber angles within the wheel to really target the load paths that the wheel sees.
Yep.
And all of these elements of the technology and the differences between the two were heavily driven by the customer's design requirements. So it was a larger diameter wheel, so it went from a 19 by 11 inch wheel to a 20 by 11 inch wheel on the front of the vehicle. But all of the load cases were a fair bit higher as well. It's a much higher performance car with additional suspension componentry and aerodynamics. So, despite being a higher performing wheel, a larger wheel, it's effectively got a larger volume to it because of this filled hub concept.
Yep.
We re-engineered everything and it effectively achieves the same mass as the 19-inch GT350 wheel. So, that was a real bow in our cap in terms of, a significant advancement forward in the product.
Yeah, cool. Interesting. So I guess maybe we could talk a little bit about some of the benefits of carbon fiber wheels compared to alloy. If there's any others apart from, we know they're lighter.
Yep.
And they can be stronger. What about fatigue and stuff? Is there anything in that sort of area that you can cover?
Yeah, sure. So I guess from a fatigue performance perspective, all of our wheels are designed and have to be tested to reach a certain fatigue life threshold. Carbon fiber itself behaves very differently compared to an aluminium wheel from a fatigue perspective. The way that it's engineered is really important in achieving that. And so it's one of the things that we, from the outset, when we're designing the wheel, just virtually in the computer, fatigue performance is probably one of our key criteria that we have to meet.
Yeah.
In terms of some of the benefits of a carbon fiber wheel over, a cast alloy wheel, weight is obviously one of the major advantages. So typically our wheels are around about 40% lighter than a cast alloy wheel.
Yep.
And that has some massive flow-on effects, given that it's a wheel and it's also unsprung and rotational mass on the vehicle.
Yeah.
I think in one of our early studies, we kind of concluded that for every kilo of unsprung mass you save, it's equivalent to sort of 5 kilos of sprung mass in the vehicle. So just to put that into numbers, you know, on our GT350R wheel, we saved roughly 6 kilos per wheel, which is sort of 24 kilos across the vehicle, which, you know, if you use that 1 to 5 sort of rule, it equates to close to 125 kilos of vehicle mass saving, which is kind of like kicking one of your big mates out of the car whilst you're trying to drive it. And so you can all realise the performance benefits that you have just from a weight perspective.
Absolutely.
I guess, yeah, there's a number of other trickle-down effects. One of the really interesting ones that we've had a lot of feedback on is the reduced noise and vibration and harshness of our wheels compared to alloy wheels.
Okay, yeah.
And that's intrinsically linked to the sort of the inherent characteristics of carbon fibre composites. So a lot of people say the minute you jump into these, into a vehicle with, you know, Carbon Revolution wheels on it, everything's quieter, the road noise is so much better damped. And so, yeah, look, there's some of the really tangible, you know, physical characteristics that you see with a carbon fibre wheel over a cast alloy or a forged alloy wheel.
Yeah, cool. We have had Sorry.
I was just going to jump in, Mark. Sucks you. How do the wheels go? I'm not sure on your background with this, but with heat and like dealing with, you know, if you're in a high stress situation, say if the car was in a road race or something, or like on a track day or something, how do they
heat
go
from the
dispersing
brakes?
heat?
Yeah.
Yeah, so obviously your brakes get pretty bloody hot when you're running around the racetrack. So you can be looking at temperatures of, you know, 300, 400, 500, 600 degrees Celsius. So in a few of our programs, we have a thermal barrier coating that we apply to the inside of the barrel as well. And so that's a ceramic coating inside that deflects the heat away from the essentially the resin that makes up the wheel. So you know, plastics can soften under heat, but having that thermal barrier coating stops that heat penetration through the rim of the wheel and into the face of the wheel as well. So that's one way that we work with that, as well as working with the chemistry of our resin systems and quality checking all of our wheels to make sure that they meet the glass transition temperature requirements before we put them out at the door.
Yeah. Mark or Tim, either of you might know, or whether you can tell us or not, I'm not sure, whether you just said about the chemistry of the resin, whether you are able to raise the glass transition temperature significantly higher than the average sort of resin? Like, has there been much development with that over the years, or?
I know that just broadly speaking, it's kind of similar to when you work with metals. With heat treating metal, you can alter the properties of the material by heating it up again after you've molded something with metal. It's similar with resin. We put our wheels through a post-cure cycle as well, and that settles all of the internal stresses that are still there from molding and raises the glass transition temperature as well. And like I said, we test every single wheel to make sure that they meet that temperature threshold, so they're all safe to put on a vehicle as well.
Right.
Tim, do you have more to add to that from a chemistry perspective?
No, I guess just probably just to add to that, you're definitely right. I guess one of the things that we take really seriously is we do a lot of materials development work. So we work heavily with, you know, Deakin researchers. We also plug them in directly with suppliers to develop new resin systems. We've got a project at the moment developing a bespoke resin system which has got a much higher glass transition temperature to that of, you know, commercially available resin. So we've got some really clever people. I can see Aaron Brighton's in on this, who's leading that program. He's probably chomping at the bit to jump in to this question, but
you can upgrade him if you want.
There's definitely a lot we do with materials development. It's sort of really the forefront of the product design. is the materials that we have available to architect into the product.
Yeah, cool. That was super interesting. We did have a question in the Q&A come through then. I'm not sure if you've seen it, Tim. We've kind of been over it in terms of the carbon fibre compared to alloy rims. We've definitely been over the pros. Would you say there's any cons? I mean, you can't throw carbon rib in the dirt, but yeah.
Look, I guess it is the cost is probably one element at the moment, which is something that we're working on reducing. Look, there's a stigma out there that, you know, a belief that carbon fibre is brittle, and as soon as it takes a bit of an impact, it will just explode into a shard of a million pieces. And you know, when you watch Formula One, you'll see that happening. But that's very much because that's the way that material is designed to absorb energy through, you know, different failure modes. And that's probably one of the things that we get copped with a bit. Oh, you know, they're like, you know, glass wheels that you take one bump and they're going to break. But that's definitely not the case. We engineer them. We spend a lot of time impact testing wheels. Our customers make us impact test wheels in all different considerations. And in a number of cases, our wheels end up being a lot more robust from an impact perspective. And that's mainly because we engineer them that way to transfer the loads appropriately. And that's all comes down to how we orient the fibre architectures we choose, and then also the external geometry of the design, all aid in that. So yeah, look, I mean, I think, you know, from a carbon fibre wheel perspective, the cost is probably one of the prohibiting things at the moment, which is, you know, we're significantly working on, and to be honest, we're not far away from bridging the gap from, you know, more expensive forged alloy wheels.
Yeah, I guess.
Yeah, we have a lot of advantages.
Yeah, I guess the stigma of them being brittle will slowly diminish as they become more prominent in the OEM market, for sure. And it's almost sounds like you guys are nearly not over designing the wheels, but having to go the extra step just to prove to manufacturers that these are safe, and you will go the next step to make sure they're safe and prove it, I guess.
Absolutely, yeah. I mean, a lot of our new customers, you know, they're risk averse. If it's a new technology, they want to put it through the ringer to make sure that they're not going to have a recall or a customer safety issue on their hands. And so, we go along that journey with them. We'll test, you know, hundreds of wheels to all different cases, and we'll supply them to them, and they'll put them on race cars, and they take angle grinders to them and they grind sections of the wheel off to simulate, you know, you curb scraping it. Then they'll dunk it in a bucket of water and freeze it. And they put an absolute torture test through these wheels because they want to make sure that they've got a robust, safe product at the end of the day. And we're supportive of that. You know, we want to make sure that we do the best in our design work as well.
Cool. Yeah. We've had a Q&A question again. I'm not sure if you're keeping an eye on them, but Nathan's just asking how the weight of a wheel affects the performance of the suspension. So I guess it's just on that unsprung mass topic again. Yeah,
that's right. So there's some massive benefits there. Obviously, if you reduce the unsprung mass, then by virtue that the loads that you're imparting into the vehicle through your suspension all reduce as well. So you can then have secondary weight saving benefits by having to, you know, down gauge or reduce the mass of your supporting structure and your suspension arms and so on and so forth. There's some other massive benefits in terms of the suspension element of it as well. Generally, we see increased grip because the whole unsprung mass system and the wheel is so much lighter. It can track and follow bumps and dips in the road much better, maintaining camber angles and so forth. And all of our track testing, whenever we send a set of wheels to one of our customers, the Ferrari 488 Pista was sort of an epitome of this. The Ferrari test track drivers, they just couldn't get enough of it. They were like saying, "Give me another set. I want to just go back out." So the physical benefits, are measurable, to the driver as well. And we've seen some massive reductions in lap times of almost 1.5 seconds on certain racetracks by doing a direct substitute from an alloy wheel to one of ours. Lap times drop by 1.5 seconds per lap pretty quickly.
Yeah, cool. Super interesting.
Yeah.
True.
How do the wheels go in terms of I don't know if you can answer this one, Mark, but in terms of flexing, I guess there'll be a certain amount of difference in the stiffness between an alloy wheel and a carbon fiber wheel. How does that affect the way the wheel handles on a situation where I'm guessing you're sort of hard cornering or even just day-to-day use? I've thrown a curveball at you here.
Yeah, you've thrown a bit of a curveball. When you mention stiffness, all I think about is all the testing that we put our wheels through. So we run a lot of structural testing on our wheels during the design validation phase when we're making a new wheel for a new customer, and we test for that to make sure that the wheels are stiff enough to cope with those kind of situations. So there's one test called the rotating bending moment, and that's a pretty common test in automotive, where you spin the wheel for up to 1 million cycles, which is well beyond the lifetime of the wheel out in reality, and you load it really harshly from the center bore and outwards whilst it's spinning, and you'll never actually put a wheel under that kind of stress in a racing environment, but it's a worst case scenario and really pushes it beyond. So I think that equates to is it 100 years or something of fatigue lifetime? It's a ridiculous number that you won't meet on a vehicle. And then there's the radial fatigue testing as well, which is probably the harshest scenario that we put it through, where you put the wheel on an axle in a drum and you spin it, and then you spin the drum at the same time, and you run the wheel through a series of different cornering scenarios and loading it in and out of the barrel as really harshly to simulate that fatigue testing to make sure that the stiffness kind of stacks up on the test track.
Yeah, cool. I guess, I've got a quick question, but I don't know if either of you will have any info on it or whether it's even a thing, but just whether you have had feedback from the drivers on the handling. I mean, you said before that they wanted a whole nother set, but was there any actual characteristics that they loved, or did they notice the stiffness of the wheel, I guess? I mean, you probably weren't there, but yeah.
I'd love to be able to give you firsthand evidence of this, of me being able to say I've driven a Ferrari and this is how it feels. But no, look, the feedback that we typically get is that the steering response is so much more direct. So when they point and shoot a vehicle, it's there. It turns in. The wheel feels like it pulls and accelerates a little bit harder out of corners. It brakes quicker. You don't have the rotating mass of a heavy wheel. They're the sorts of things that we typically get as feedback, and it's always been the numbers kind of don't lie. As I said, this one back-to-back comparison we did with a GT3, a Porsche GT3, where we ran an alloy, the Porsche GT3 alloy wheels, and then did a direct back-to-back. It was across one lap, 1.4 seconds, which sort of equates to about 7 car lengths when you cross the start-finish line, which is, a massive gap.
Massive, yeah.
Yeah.
Yep.
Just one more thing I had before. In terms of, I guess, putting the wheels on the car, standard car will have standard steel, whatever, lug nuts that put it on. How do you go with what lug nuts do you use, I guess? Are they any different to normal ones, or
No. We typically can use the standard lug nuts. A lot of our OEM programs typically opt for whatever they would use on an alloy wheel, which is a steel lug nut and a steel stud. In some cases, we've used titanium hardware to really reap the benefits of weight reduction. But the interface between the carbon fibre wheel and all of the attachment hardware, so where it attaches with studs and lug nuts, or some cases with bolts, is all aluminium. So we engineer specific inserts and what we call backing plates, which then attach to the carbon fibre wheel as an assembly, and then that whole thing gets assembled onto the vehicle. So, from a wear perspective, in terms of, galling of the lug nuts, we don't have that directly rubbing against any of the composite, carbon fibre composite areas of the wheel.
Yeah, great.
Want to answer this question, Trent?
So we had a question come through. So it said, when Carbon Rev first released the wheels for the GT350, so what specific specifications did Ford ask for versus other vehicle manufacturers?
Or
was there a different?
Each OEM, I guess, has their own specs, if you like, that we have to conform to. Generally speaking, there's some SAE standards that all wheels must conform to, and then the OEMs usually adopt that standard and then add all of their additional testing and specifications on top of that as well. So for us, the Ford GT350, it needed to meet all of the regulatory standard testing that an aluminium or a steel wheel would normally meet. There was a few additional tests that we had to perform, being a new technology. As I said earlier, they wanted to really torture test the wheels, and so they throw a number of additional tests at us. But in all cases, we must be compliant to any regulatory tests, as well as the customer's specifications and validation testing that they require. And there's typically two phases of that. There's vehicle or wheel level testing that happens, I guess, in a lab, you could call it, on a test rig. And then once you kind of get through that gateway and you've got a safe wheel, then the wheel can actually go onto a vehicle, and then they send it through potholes and all sorts of high temperature brake fade type tests. The real torture tests on vehicle.
Yep, cool.
Great.
Just quickly, if anyone else has any Q&A questions, send them in now before we wrap up in 5 or 6 minutes, and we'll try and get them answered. But yeah, Trent, if you...
I'll just jump in while everyone's... people are putting their last questions in. So I guess I'll throw to Mark. I sort of asked you this before, but if you could give a graduate or future graduate any advice on breaking out into the world of jobs and what things you can do at uni. We sort of talked about it before, but what would be your advice on that?
Yeah, definitely the thing that made the biggest difference for me, aside from being involved in DES, was there's actually, I'm surprised how few students know about it, but there's actually a service at Deakin called Deakin Talent, and they do a lot of workshops on resume building and LinkedIn workshops and that kind of stuff, and they actually offer tailored resume reviews. And so when I was putting together my resume to start looking for internships during my last 2 years of uni, I took it to a few different places and said, hey, can you review this, give me some feedback? And they rip you to shreds. They absolutely tear you down. And if you've got the guts to go around and get some honest feedback from people that aren't scared to tell you that it's rubbish, you can swallow your pride and end up with a really good looking piece of paper. So the first step to getting any job's a resume, but there are so many shocking ones that I feel sorry for HR for having to read. So if you get along to a Deakin Talent workshop and then follow the steps and really put the effort into it, because it's not easy stuff. Like, it separates, the boys from the men, putting in the work to your resume and putting in the work to get feedback on that kind of stuff is tough to hear, but it, it toughens you up, makes a big difference. Mock interviews and that kind of thing. There's heaps of resources like that at Deakin that you can tap into.
Yeah, great. I guess, Tim, I'll throw the same question to you if you had any advice for graduates and that from a more from a higher up in the company.
Yeah, it's a really good question. I guess when we're interviewing either graduates or engineers or prospective sort of employees, one of the things we kind of really look for is the attitude, of that person. Have they got the right sort of cultural fit for our business, and do they have an attitude which is sort of conducive to the team that they'll be coming into? There's a lot of things that you can learn in the technical skills, which are generally part of your engineering degree, and so a lot of the time in interviews we're asking questions, sussing out not only have they got the technical ability, but do they have the attitude and the culture to work well within a team. And so for a graduate, I'd suggest one of the best ways to do that is to really expose yourself to different environments, and build up that portfolio of work experience. So if you have to go and do a bit of free work experience somewhere to gain some experience and some knowledge around not only from a technical perspective, but how different companies and different businesses operate and function. They're the sorts of things that we want to hear about. What previous experiences have you had? What was your contribution, in that team, for example? And so that'd probably be one of the key things that we look at, aside from, obviously having the technical skills.
Yeah, so that's good. I guess, as you were saying, taking on free work experience or anything like that, it's a big help. And getting any experience you can, even if it's not in the field you want to be in. I mean, I know personally, Mark, you did your internship, something to do with milk, wasn't it?
Yeah, my placement for uni was at a dairy processing engineering company, so totally different to what Carbon Rev does, but that was such a valuable experience. Like, I'm kicking myself that I didn't start it earlier in my degree and left it to my final summer holidays like everyone does. If you do it earlier, you start to connect the dots between uni and where you apply things differently. So I wish I did it earlier, and I wish I also did a second one as well, because even just things like learning how to have a schedule where you get to work on time and you work solely all day and you time your coffee at the right time so you're still not tired at your desk all day. Like, that's the kind of stuff that you've got to learn as a graduate, and that's probably harder than making a bloody carbon fiber wheel some days. Like, there's so much stuff you don't learn until you're working, that you can only get that experience from being in a factory or being an engineer. So if you do it earlier in your degree, you kind of see what you're up against when you graduate.
Yeah, any experience is good experience. And it sounds like if you can get it at a few different places, it's the way to go. Open up your insight into how different companies work in different industries. Yeah, cool.
Yeah, definitely. All right. So if there's no more questions that have come through, okay, so we'll wrap up. So thanks to Mark and Tim for giving up their nights to come and talk to us about Carbon Rev. Really, really appreciate you guys coming down. Yep. Matt, thanks for helping out hosting again, as always.
No worries.
So where can people go to find out more about Carbon Rev, I guess?
Or even careers and stuff, yeah.
Yeah, if you have a careers board or something.
So we obviously have a website. Jump on there, have a bit of a look. If you trawl through YouTube, you'll find some clips, not only from Carbon Rev, but some other clips from like Ken Block. I don't know if anybody's into that type of stuff, where he's talking about the GT 500 wheel and that type of thing. So there's some pretty interesting things that you can find on YouTube these days. And then, yeah, we often advertise through Seek. But yeah, look, it's just keep your eyes and ears open. You know, we're all on LinkedIn these days. Social media is pretty live and active for us as well from a Carbon Rev perspective. So, yeah, we're really super keen and excited on the benefits that we've had on these internship programs. Some of our best engineers in the company have kind of come through from interns to graduates, and then have really grown into, we call them weapons within the business. You know, they can just come in and get everything done. You know, they've got the right keen attitude and also the technical skills to be able to do that. So, you know, we're highly supportive of that internship graduate engineering sort of program. And there'll be definitely more of that happening for us.
Cool. Exciting.
Yeah, great. Very good. So,
Right.
yeah, thanks for everyone that attended. Thanks again to Mark and Tim.
All right, thanks
Just
for having
quickly,
us.
yeah, no worries. Just quickly, if anyone is interested in Des after tonight in terms of any networking you want to do, feel free to sign up using the link that's behind me, or check us out on Facebook, and that's where you'll find all heaps of information, and you can contact us through Facebook as well. So yeah, thanks again,
No
and
worries. Thanks for coming, guys.
enjoy
Thanks,
the rest of
guys.
your nights. Thank you.
Guys, cheers.
Cheers.
See ya.